All right, so now I got to go to, I'm going to go to 3 tight here because I'm a couple minutes after. We got 66 people. That will continue to grow. Okay, so there are a lot of, Matt, you're going to love this, but there are a lot of like David Engleharts out there and Nihads and Ryans and Mr. Abbasis and these guys who have come to these programs. So what they will typically do is when people ask for the Menti code, they are so good at saying, there it is. So I don't have to worry about the Menti code. Well, all right. As soon as the image comes up for for the MCC, we are going to do the introduction and get this party started. All right?
Sounds good.
All right, Matt. Actually, why don't we do this? So welcome to the session on Motor Control Center applications. My name is Thomas Dimitrovich. I'm with Eaton, Vice President of Technical Sales. And I have been doing these programs. And if this is your first program or time with me, we're going to do 2 hours. We do professional development hours. But you have to log in with the Menti code at the beginning and the end. Hopefully you were here early enough. If not, use the chat and ask for that Menti code, and I'm sure somebody will be out there to give it to you. Anyway, I have a special guest with me, Mr. Matt Hussey, product manager out of our Motor Control Center group, and I'll let you introduce yourself while I take care of some other details. All right?
Yeah.
All right, take it away, buddy.
This is Matt Hussey. I'm with Eaton's low voltage motor control center product line. I'm a product manager. Been with Eaton for almost 10 years. Actually, Tom, you and I first met back when I first started with Eaton, and you were in, I believe, Resi at that time. We're both from the Pittsburgh area, but I live in North Carolina now.
So where's our plant in North Carolina?
So yeah, we've got our main plant here in Fayetteville, North Carolina.
Fayetteville.
Yep.
Excellent. I think I was online. I was talking about it last week, or the week before. I was talking about this, and I couldn't remember if Fayetteville was North Carolina or South Carolina. So I was having a Friday fall Paul. All right, so today is Motor Control Center applications. We've got a series of questions we're going to work through. We're going to dig into as many details. Please use the chat for your questions. And what we will do is both Matt and I will keep a monitor on the chat. The Menti code is 648150. So write that down, 648150. Go to menti.com. Mr. Sandeep, go to menti.com and go to, what was the number again? 648150. So 648150 and menti.com. And enter your information, and we will do a different number at the end. So today is, I'm just putting this in, 648150 is Menti. All right, so Matt, I appreciate your time, and we are going to kick it off into have a great discussion on motor control centers. Are you ready?
I'm ready.
Awesome. So we would be amiss if we did not at least point people to the right area in the National Electrical Code. And my reference that I'm using is the 2020 version of the National Electrical Code. So I will be reviewing, and if we go to code references, if we pull up any code documents based upon your questions, we are going to be, excuse me, we're going to be referencing the 2020 version of the National Electrical Code. And if you look in Article 430, it covers motors, motor circuits, and controllers. And again, the article covers motors, motor branch circuits, feeder conductors, and their protection, motor overload protection, motor control circuits, motor controllers, and motor control centers. And the specific, what part in 430 covers MCCs? Do you remember?
Part 8.
Part 8.
Should be.
Part 8 of the National Electrical Code is the area of the code that focuses solely on motor control centers. But if you look at the overview of, I believe this is in 430.2 or 4. Double check. It's right, or 430.1. I think that is. Yeah, it's 430 figure 430.1, which is your overview. And I love this, and I wish, I was almost thinking about doing a public input, Matt, on like on transformers and a few other places to do the same type of layout with regard to where in the code do you go to protect like all these different parts of the pie when you talk about motor protection. I really like this.
Yeah, it shows a lot of the elements and everything like that. Certainly it was helpful for me when I was first learning it all.
Yeah. So then you put this together. Why don't you talk through this a little bit?
Yeah, I ended up having to craft that myself because especially when you start navigate a lot of the standards that are out there, motor control centers have a standard themselves, but then, we're applying a whole slew of devices that have their own standards. So I was trying to kind of get a good visual showing, okay, there's all the standards for the disconnects, the overcurrent protective devices, the contactors, the overloads, and how those devices are tested and built out. So it kind of provided a lot of good guidance for me to understand as well. We've got other installation codes as we're talking about with the National Electric Code, 70E, electrical safety in the workplace, to NFPA 70B, how equipment should be maintained. And then we've got some other standards listed below there in the IEEE where, we're doing a lot more from electrical safety and whatnot. So,
yeah, so I noticed from the motor's perspective, you've got NEMA MG1. That really highlights that. So what I like about this is you've listed all of the UL standards associated with the different products right down in this left-hand column. Really nice. UL 489 is the circuit breakers. UL 98 is your switches, right? And then UL 248 are your fuses. And 4248 are the fuse holders that would go inside of all of the equipment. 508 is your industrial control panels. And you say UL 508 now, UL 60947. Did a transition happen there?
Yeah, there was a harmonization there with UL 508 as well as IEC 60947. Now it's kind of a unified standard to work off of.
Cool beans. And then we got another UL 98 switch down there for the local motor disconnect. And then what's this column over here? It includes the drive. That's the big difference there, right?
Yep.
Yep. So you have pretty much everything the same here. So that drive replaces all of that equipment, the motor overload protection and your controller, and it provides that interface in between the power distribution system and the motor, and controls that circuit.
Yep. And obviously there's other things that could be added here, like a panel board or UL 67. So UL 1008 transfer switches, things like that.
You just broke up. Can you repeat that?
I was just saying, obviously have different things like UL 67 panel boards, UL 1008 transfer switches, and a whole bunch of other things. But these are the main motor control applications that I think everybody thinks about.
So what about this over here?
So in reality, if somebody's out there, say, specifying the equipment, pretty much those are going to be their kind of main reference points. So UL 845 is the standard that MCCs are tested to and listed. ICS 18 talks about how the equipment is constructed and things like that, but 845 outlines how it's tested. And then we've got environmental ratings. So you got NEMA 1, 12, 3R, things like that. UL 50 kind of outlines how you actually go about testing for those different enclosure types.
Okay, we got a comment. You got to speak up, buddy.
All right.
Get some energy behind them vocals. All right, so they're saying they can't hear you. So you gotta. I don't think it's the volume issue. Just I got you up. I think I have you all the way up on my side. So I'm just gonna double check, make sure that I don't have you down. All right. Okay. So let's. Anything else on this one?
No, I think we'll end up talking through a lot of these points as we go on here.
All right. And then, as you pointed out earlier, motor controls, the part 8 is, and what I'm going to just do real quick is I'm going to go to part 8. Part 8's not that big of an area of 430, is it? Part 7. Part 8 goes from section 430.241 through 430. Looks like 245.
Yep.
Yep. So you got general requirements in 430.241. You have stationary motors. Talking about the frames of stationary motors shall be grounded under any of the following conditions. So we're talking about, I guess they really mean bonded, right? And portable motors. Wait, help me. Wait a second. Nope, that's the wrong one. That's 13. I was like, wait a second. What does that have to do with motor control centers? Part 7 is motor controllers. There we go. Part 8, motor control centers, is 430.92. This makes more sense. 430.92 through 430.99. You do have your general requirements. It covers motor control centers installed for the control of motors, lighting, and power circuits. Lighting? What's up with that, Matt?
Yeah, we can do something like a full voltage contactor and use it for lighting of loads. Maybe you've got like a parking lot or a facility. You might have a contactor that switches on once it gets to be dark out.
Okay, cool. So they have to be provided with overcurrent protection. We're going to be talking about that in accordance with parts 1, 2, and part 8 of Article 240. So it points us back to 240 for overcurrent protection. Talks about the ampere rating and settings. We got, and it says 430.95 service equipment. So we could have a motor control center as service equipment. Is that right?
Yeah. You can get a service entrance MCC.
Sweet. And we're going to talk about that too, right? Because we got the line side barrier issues that we got to think about and a few other things. Grounding, multi-section motor control centers have to be connected together with an equipment grounding conductor. So we have to think about all of those vertical sections and how they're put together, and they have to be bonded together. Is that right?
Yeah. You'll find a ground bus that's usually run continuously across the lineup.
All right. So you're kind of choppy. If you're watching the don't watch the YouTube video either. So because I think that's eating up your bandwidth. All right, combination motor controller, is that a MCC? That's the first question we got of the day. So I put some images in here that that pertain to. I mean, that's your combination motor controller. That's got your overload in there and your disconnect, right?
Yep. Yeah, you got your branch short circuit protective device, your overcurrent contactor.
But I don't think that is what they're talking about. I think that they were thinking of something like this, which is your combination motor starter, right?
Yeah, because here you got it all installed in an enclosure, but you got your same basic elements. You got your contactor, your overload, your disconnect, all in one enclosure.
And that's not a motor control center, is it?
No, we actually have a little bit more going on in there.
So so what I did was thanks to you and a few others, we put together some images of motor control centers. So as I walk through some of these images, you'll see, they can be quite extensive. Like this looks like it has 1, 2, 3, 4. So Matt, on this one here, so I'm counting the vertical sections, right? So that's one, that's one,
Yep,
that's one. Now what about this here? Is this all one vertical section, or is that two?
that's one vertical section, and actually the compartment doors kind of open up, kind of revealing like a big area. So they probably have like a disconnect and a large drive in there. So that would be one section. You can almost see, at the top of each section, there's a white label, so that would actually be another way you can count up the number of vertical sections too.
Oh, I see that. So there's a white label there. There's a white label there, and then there. Okay, so we got 1, 2, 3, 4, 5. 5 vertical sections there, and then you don't do a lazy Susan on these, do you?
No, it's a corner section. So there's bus that actually runs through there, and then you got a whole slew of
Okay.
sections off to the right there.
All right, so you got 1, 2, and that's just one section, and then that's one section, 2 big ones, and then you got one there, and one there. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 vertical sections. What are these circles here? What the heck is that? You locked up, buddy. I lost you, Matt. All right. First technical difficulty of a live session.
You there, Tom?
Now I got you. I got you back.
Okay. I was just saying, so those are fans for like a drive. So if they require cooling and things like that.
All right. So each of these round things are fans. So we could say that in there are probably variable frequency drives that need cooling.
Yeah, that's correct.
All right. Is there do they do anything special with regard to like filters or anything? Like if I have an area that's dusty?
Yeah, they'll have filters with them. Maybe not seen from this picture, but there'll probably be some like even on the backside, which could be taken out, maintained, placed, washed, cleaned, you name it.
Okay. Cool. All right, so there's another big lineup, and I'm seeing big breakers in there too. I mean, something that I would see probably in a panel board, and I'm looking at meters. These are your analog meters. So you can pretty much specify, and there it looks like there's so there's 1, 2, 3, 4, 5, 6 vertical sections. Would they have all been? Would you order all of those together?
Yeah, that would be one complete lineup. Typically, everything is, engineered. It's going to be set in place as one lineup. But typically for shipping, you'll see that, broken out into multiples of 2, 3 sections to make it easier to transport. And then you end up assembling it all together on site there.
So I'm looking at the chats because my browser's working finally. And Javier asked, can you put arc resistant back to back?
Yeah, you can. Arc resistant constructions support the ability to provide containment for arc flash incidents that could occur in the equipment. And so a lot of the configurations allow for bolted back-to-back arrangements as well.
Yeah. And then, Matt, we had we had this discussion. What did I tell you when you have inspectors watching this, what did I tell you we're going to get on this video? I told you that people are going to be looking at this and going,
Yep.
there's a code violation. There's a code violation. And Ryan Jackson, he just made a statement. A lot of these pictures violate the new rules in 110.26A3 for housekeeping pads. So that because he brought that up, let's take a look at 110.26. Boy, my eyes are getting bad. 110.26A is working space. So working space is important. And we know the 2020 codes change did a lot of, the 2020 cycle did a lot of changes around working space, especially for large equipment. But 110.26A3 talks about height of working space. The workspace shall be clear and extend from the grade floor or platform to a height of 6.5 feet or the height of the equipment, whichever is greater, within the height requirements of this section. Other equipment or support structures such as concrete pads, I love it, associated with electrical installation and located above or below the electrical equipment shall be permitted to extend not more than 6 inches beyond the front of the electrical equipment. Housekeeping, excellent. Look at that, huh? That's just hilarious. It's I told you that was, I knew that was coming. Now what I was waiting. I'm waiting for some comments about maybe this arrangement over here. What do you guys think of this one? What do you think of the transformer up over top of that, Ryan and Don Gannier, and others? What do you think about that? I'd love to see some comments on that. All right. Moving forward, we must progress. Okay, now, to understand what a motor control center is, I went 2 areas. I went to the 2020 Code Article 100 to the definition of motor control centers, and it says an assembly of one or more enclosed sections having a common power bus and principally containing motor control units. Matt, do you have any idea why they said and principally containing motor control units?
I would have to expect that that's probably because majority of the units are inclusive of motor control center units. But there could also be distribution applications too. So you have branch feeders and whatnot.
Yeah. And Ryan Jackson says that transformer's fine. 450.13a allows it. Great reference. Thank you, Ryan. And yep, and Don Gannier does not appear to be of the type required dedicated equipment space. So that's good. That's good. When I first saw it, I was like, I don't know. I'm gonna probably get a comment from that, but that's good. I'm glad they looked that up for us.
Good to know we have our backstop out there.
Absolutely. You know what? I tell you what. When you got Don Gannier, Ryan Jackson, Mr. Abbasi, Dave Englehart, and all these guys on you can't go wrong. You can't go wrong. They'll keep you honest. That's for daggone sure. UL 845 is the standard for motor control centers, right?
Yep.
And I believe 845 goes for 600 maximum 600 volts.
Yep.
Okay. So I looked at the definition. I call it a definition. It's in 3.13. I'm not sure if Section 3 is definitions or not. I'd have to look at the standard. It says a floor-mounted assembly. So it tells me that a motor control center has to be mounted on the floor. Can't be mounted anywhere else. Is that right?
Yeah. All constructions are built to be freestanding.
Freestanding. So I don't have to mount it against a wall. I can put these right in the center of the aisle of a room if I wanted to.
Yep.
I can put them back to back.
Yeah. That's what we were talking about a little bit before there with the arc resistant application.
Right.
So you could have it could either be back to back for 2 different incoming feeds, or it could be a common shared bus between the 2 as well.
Okay. And then and I could have swore I saw something. I saw the word principally in here too. Typically having a horizontal bus, power bus, and principally containing combination motor control units. So to your point earlier, which we're going to have a discussion of, we can put other things in there because outside of just combination motor control units, we saw meters in there, we saw circuit breakers in there, all these other different things. So That's an important thing. So now it says usually units are mounted one above the other in the vertical section. So when they say units, we know those in what did you called it, industry terminology of a bucket, right?
Yeah, you'll commonly hear that used to describe it because it's really a kind of a self-contained. I don't know if you want to go back to like a previous picture, but
So each one of these is a unit.
yeah, each one of those compartments. Yep. Behind each one of those units, and they're capable of being withdrawn, inserted, removed, plug-on connection there to the bus.
Okay, so each one of these has a bucket that can be removed, and we'll
Yep.
talk more details about the different innovative things that people are doing in that area. But okay, so I get that down. So motor control center, floor mounted. My MCC buckets are one over top of each other. I don't make them horizontal. There's no such thing as a horizontal MCC it's all, they go from the floor up, right?
Yep, that's
How high?
correct.
How many units high?
Typically, they're about 90 inches tall as a vertical section, and then you also, in each vertical section, you're going to have wireway space. So then that usually leaves about 70 so inches to work with, depending on manufacturer. Usually, you'll hear that get subdivided up into compartment heights that are maybe 6 inches tall to 12 inches tall as a typical. So you get about maybe 6 to 12 units per vertical section.
So overall height from if I'm standing in front of an MCC, what's the top of that MCC? Is there a maximum that the standards tell you, or is it just driven by the handle as far as how far away the handle needs to be from the floor?
Yeah, you're thinking of the top of the disconnect. I think the 2 meter rule. But yeah, MCCs are going to be 90 inches tall, across manufacturers.
Okay.
They can be shorter.
What's the shortest
you know,
one you've ever made?
we've actually made one that was about, it was under 6 feet tall. So it was kind of cool whenever we were seeing it go through a shop. You had somebody kind of leaning on it with their elbow on top.
That's pretty cool. Yep.
Yep.
Excellent. Excellent. All right. So you have, if it's one vertical section, there's no horizontal bus technically. I mean, there's a bus at the top where you connect, but if when you put these next to each other, there's a horizontal bus that connects each vertical section together. I think that's what they're talking
Yep.
about there. You have vertical buses and horizontal buses.
Yep.
Okay. And then, okay, now so there's a definition of a motor control section. Vertical enclosure assembly that is prevented by the structural framework from being physically separate. Okay, I got you, into smaller parts. So that's that's each of those vertical sections in that one slide we saw. So that definition basically is are these puppies right here. So that's a vertical section. That's a vertical section. Piece of cake.
You got it, Tom.
See, I'm becoming. I'm going to become a guru on this because of you, buddy. All right, so the function of the vertical section is to support the horizontal vertical buses, units, covers, doors, all that good stuff. All right, so now this one here talks about what's not covered in UL 845, which goes to the question of the requirements do not cover switchboards or panel boards intended for control of electric light or power circuits, because really, technically, I could you put some of these motor control items inside of a switchboard?
You could.
Yeah.
Yeah, there could be lighting control, other applications for that.
Yep. But that would be covered by the switchboard standard, not 845. Just
Correct.
because you're controlling a motor in a large gray box, which with a bunch of compartments, doesn't mean you are a UL 845 type of structure.
Correct.
All right. Now, so what I did do is the UL product code is NJAV, and what I was planning on doing, hopefully if I can, for this group, if you have never been to UL's product IQ, I'm going to walk people through that real quick and show you how to get to it. Basically, from a blind URL type of perspective, you go to ul.com. We've got 114 people out there, which is a good thing. You go to ul.com, you go to resources. Oh, yeah. So I click on resources, and then over here on the right, I thought. Yep. See where it says certification database, UL product IQ. Now I'll tell you, I'm already logged. I should be already logged in. I don't know. If I'm not, I'll log in. But nope, I'm not. So you will log in, and hopefully I remember my password. Oh no, I'm already in. So I'm logged in as Thomas. It's just slow. And then it's totally free. You just register and whatnot. You come in here and you type in Motor Control Center or whatever product. You could type in molded case circuit breaker, switch, receptacle, AFCIs, GFCIs, whatever it is. And these bring up what used to be in the white book, which is now the I'm going to do something here real quick. I'm just going to do 3 so people see 3 on the screen. So this is the nav guide for motor control centers. You'll see motor control center certified for Canada. You'll see retrofit motor control center units. We'll talk a little bit about these types of things. I'm going to go to NJAV, which I alluded to earlier. And in NJAV, you have all of the, you have the general. Now, this description that you see here, I'm going to zoom in if I can. This talks about what UL has done is pulled information out of the standards because other people, we're as a manufacturer, we would have these standards because we're listing products, and believe me, we pay for them. But we have access to all of the standards for the products that we are listing. But inspectors and contractors and others, design engineers, don't have access to this. But this information is really good information. They pull stuff out of the standard, things that you need to use, understand. They talk about marking. They talk about the product identifiers, related products, additional information, any requirements. It talks about what standard that it's listed to, what the UL marks. So this is a great reference that I think if you are, if this is something that, if you're engaged in inspections or you want to learn more about these types of solutions, then, that product IQ is a good reference for you. So I just thought I'd share that with everybody. So what about voltage, Matt? I said earlier that standard only goes up to 600 volts. Can you buy a medium voltage motor control center?
Yeah, you'll find that it's listed under UL 347. So those would cover applications above 1,000 volts.
All right. So we have a different standard for medium voltage than the other. So that's. But you can get a motor control center. I think it's the components inside are a lot different. The size is probably a lot different, and some of the capabilities are probably enhanced for the medium voltage applications.
Yeah, you may only be able to get 1 or 2 units per vertical section there.
Yeah, that's true. And they're not 12 inches deep, right? Tall.
Nope.
No. This is that same document, and then I noticed you did not include the medium voltage stuff over here.
No, I had just focused on the low voltage one for a lot of these standards.
You know what? Somebody just brought up an interesting part of this, so bear with me. They said if you scroll down, Don Gannier says if you scroll down on the first page of Product IQ to installation code search, dashboard. Let's try this. I've not done that. I remembered it as it was a finished goods authorized product IQ database for enhanced search functionality, materials, other. There we go. Dampers, FHIT, fire codes, installation code search. There we go. Look at that. Keyword, installation code, say 240. Let's not say 240. Let's say 210.12. I don't know. Installation code. Oh, here we go. What am I doing? I have to do the, this is pretty nice. So Dawn, this is a really nice little tool. There's the National Electrical Code. You can click the year. We can click 2020. We can click the section. Oh, look at this, Matt.
There you go.
Like if we, so 430, let's go back up to 430. I wonder if oh yeah, so 430. 430.1. Look at that, motor control centers. So you could, oh, this is really nice. Really nice. Don, Mr. Ganir, thank you very much, buddy. We're going to minimize that. So appreciate that feedback, Don. It's good stuff. Okay, so I think we got a good feeling for what an MCC is. Can I take a bucket of an MCC and put what I want in it? He wants to put a breaker in there to feed another panel board. So this guy sent the question in saying he has a panel board he has next to it. He has an empty bucket or a spot in there. He wants to take the bucket out, put a breaker in there, and run a feeder over to that panel board. Matt, can he do that?
Yes, he can. Yeah, there'll be a UL listed unit that manufacturers can ship out. Would basically be able to go back into that open compartment, and it would come with all the necessary hardware and things like that to install it.
But wait a second. I don't want to buy anything from you. I've already got the bucket.
Oh, you got it already?
Like I say, I got the bucket already, and the MCC is sitting there. Can I just install a circuit breaker in there myself and, pull the conductors in, power it up, and take the feeders out? Can I do that?
Not under that construction. There's some, specifics on how those units are arranged. Each bucket has its own listing to be able to fit into there. So unless they've had something that's like a spare that wasn't being utilized, they would be able to utilize something like that.
All right. So and you mentioned listing, and I called this one out. So this is the bucket, right?
Yep.
That's the bucket, and this is all the stuff.
Yeah.
For lack of
you can kind of see the connectors there at the top, where it actually shows there's specific power connections being made there. So that whole unit is what's listed, not just the components.
Okay, so you as a manufacturer, so you put these together. How do you test a bucket? What do you do to test that?
You'd have to have a listed section, as a sample, and that unit, would be identified. You'd mark down, say, all the different connections to the bus, that all the hardware that's included in there. It has to be tested, one, for like a heat rise perspective, so to make sure that we're not, going to be able to go too hot where we're melting insulation. And then we actually do a short circuit test, so that door is normally closed, so you have to make sure that, if there is a bolted fault, that the equipment is able to withstand that event.
Okay, so this is a listed unit, and I did a close up on that label, right? So that really shows that unit is listed. Now, Don Ganir asks, can I take this starter out and say there's a circuit breaker? Say this was, instead of a fusible, say, okay, it's a fusible disconnect. So it's a fusible disconnect. Can I just take and go from here and run a feeder out to a panel board and call it a day? Am I allowed to do that?
Yeah, you might have, a field evaluation to make sure that, there's nothing wrong with it. I mean, obviously you're changing it from a starter unit to a feeder application,
Right.
which, so that unit as it was originally listed was as a starter compartment. So you might need a follow-up there just to make sure that all the components are adequately sized and whatnot.
Right. And so, Mr. Gio Barone made a very good point that if you if you're looking at an MCC bucket and say there was an HMCP in there, so an HMCP does not have an overload. It's an instantaneous only. It's not a listed branch circuit overcurrent protective device.
Yep.
It provides
It's a
short circuit protection only.
That's right. It's a UL recognized component, so
Right.
has to be part of a combination.
Now, if this so this is a fusible disconnect, Matt. So I would assume I'm thinking of the fuse. I know I would the fuses that they put in there are going to be listed fuses because that's what we
Yep.
use to protect motors. The switch itself would not. It's doing is disconnecting. So there's nothing part of the switch. So if it was a fusible MCC with the fuses in there, you wouldn't have the same concerns so much as you would have if you had an HMCP because the HMCP is instantaneous only. But there might be other issues. I can't think of stuff like if it's a fusible area versus a breaker area, but
Yeah,
suffice it to
you have to consider not only the components but the volume it's installed in. Right? Because all this what we're talking about as far as like temperature rise and short circuit are all things that are also described in a certain space that it's utilized in too.
that's true. That's true.
So you couldn't just automatically, upsize. Say I've got a 10 horse application and I want to basically upsize it to 15 or 30 or something like that. Yeah, I might be able to fit those, but over time that size is also a consideration because it needs a certain amount of space for temperature, performance, as well as short circuit.
Good point. Good point. So I think one of the key thought processes here is that which I never knew this until not too long ago, relatively speaking, that bucket is a listed bucket. And I think you are the one who sent me a website of a company that was advertising. They got like 4 variable frequency drives. They were advertising that they did this. They can fit a lot of stuff inside one little a bucket.
Yep.
Which
Yeah, and I think that's the kind of hidden detail behind all this. It's really easy to see how things are mounted and installed and physical space, but the part that goes through from what each manufacturer does from a testing perspective, you often don't see that. It's really that combination of conductors, the connectors that go onto the bus, the size of the unit, et cetera, that are all evaluated together.
That's right. Now, in the National Electrical Code, there's no place that says that it has to be a listed motor control center. It has to be a listed bucket. It has to be a listed motor. There's no requirement. The circuit breakers don't even have to be listed. There are products and solutions that are required to be listed, but what AHJs will use is that listing mark so that they don't have to go in if it's not a listed product. They're going to have to look at every one of those components. They're going to have to figure out how are they going to consider whether or not the short circuit current rating of the equipment is adequate and all that good stuff. So it puts them in a difficult position with regard to approving something. I know some jurisdictions will, like Donnie Cook in Shelby County, Alabama, they have a rule that says all products are going to be listed when they're installed, and he has the ability to say you're not using unlisted product. But if you go back, I can't remember the section. It's back in 110. I know 110.3b is what they use for looking at manufacturer's instructions, but I think it's in 110.3 that talks about examination. That speaks to Anyway, Brian or one of these guys will probably know. There it is. So look at it. So Ryan Jackson says nothing. I love it. Nothing that he knows of requires a listed MCC. I think the AHJ can use 110. I knew it was 110.3A to determine suitability if it was altered. Now, so that's true. 110.3A does give them the ability to do that. But, when you start looking at a lot of these things, when you consider heat rise, you consider the requirements from a short circuit current rating perspective, there's only so much an inspector is even able to do. And that's why they'll typically get an organization like UL or ETL or one of those organizations to come out and do a field evaluation if you start monkeying or modifying these enclosures and whatnot. As long as you're not, anytime you don't do a 1-for-1, or if you're going to, like Dawn said, hey, I'm going to take that components out. I'm going to change that HMCP out with a standard thermomagnetic circuit breaker. I'm going to feed a panel board. You are into the area of an AHJ, in my opinion.
Yep.
A field evaluation. That is, if you're even going to get an inspection, right? So a lot of that stuff occurs in plants where there's no inspectors. They don't have to pull a permit to do it.
Yeah, you got a lot of industrial sites that have owned this equipment for many, many years.
Yeah. And then this is showing that's a. I called it a router. You called it what? A switch?
Yeah, that's an Ethernet switch.
Ethernet switch. Yeah. What's the difference? It's Ethernet switch and a router. I mean, they're the same daggone thing.
You would think so, but I would say a breaker and a fuse have some different performances, wouldn't you?
Yeah, that's true. That's right. No different.
Different capabilities inside.
Yeah. Now, this bucket here that we're showing, you pointed it out. I when you sent me that image, but up here it's connected to control power, just 24 volts, and there's no power in here. So can I just take a bucket like that and put DIN rail in it, and if I wanted to run like Ethernet, or if I wanted to put a little hub in there or something like that, that wouldn't.
Yeah, that's basically a relay compartment. So if anything, it might validate that the devices have been appropriately rated. We're not invalidating any of their installation spacings and whatnot. But yeah, it's completely usable space for a lot of different applications.
Excellent. And so the other thing in there is I know that anything we can do with lower voltage increases safety because I'm below the shock thresholds and things like that, right? So
yeah,
why don't we do more 24 volt DC or AC or whatever control in these motor control centers? Usually,
a lot of the cases, it's you're trying to provide a continuity for the control applications, and a lot of times, remember, Tom, MCCs might be located and are actually controlled from process control systems and things like that are hundreds of yards away. And so one of the challenges we have to overcome is voltage drop for a lot of the coils, especially as you get up in size for contactors and things like that. So you'll see something as you might have an interposing relay utilized for low power or 24 volts. But then, contactor coils will usually still be applied at 120 volts, and really just trying to offset anything from bad power.
Gotcha.
But as equipment goes on, I think more of it we see, especially with the networking capabilities, there's a lot more capabilities on providing power reliably to those things. So you'll commonly see something like we're seeing here, where the Ethernet switch is powered off at 24 volts, and as you mentioned, to reduce any of the shock potential here, that power is coming elsewhere, but that's all that's in this unit. You don't see any other 480 volt supply or 120 volt supply.
Okay. No shock hazard at all when you open that door.
Right.
So Mr. Ford has a question. If I'm specifying if I am specifying a contractor to retrofit an existing motor control center bucket and use it as a pass-through to a new remote-mounted variable frequency drive, what's the best way to do that?
I would try to get a feeder unit, or an aftermarket unit that has either a breaker or a fusible. You might need to check with the drive as to what branch circuit protection it needs. But then you basically just add in a separate unit there to feed that. Because usually the MCC isn't designed so that you can just lug off of the bus and feed out to that. You're going to have a unit to feed out from that compartment.
So if he already has a bucket, which already has the stabs to go on the back of the bus, right? Then you can pull the power. You can put a circuit breaker in there. You'll be able to power, pull a feeder circuit off of the bus, off of the stabs, and then take that out to a separate panel.
Yeah, you would. I'm assuming in that case you're talking about that there would be a disconnect already in there that they're feeding off of.
Well, I'm not sure about his question, but I've got a bunch of questions in my head. Like, for example, let's say that the picture that we're looking at right now with that Cisco,
Yep.
and he also educated me on what a switch is versus a router. But say that Cisco switch, say I go, you know what? I'm getting rid of the switch because I need that to power this variable frequency drive.
Sure, you got this compartment here that you want to change
Right.
over to. So the challenge you'd have is there's no, in this particular unit, this unit doesn't have any power connections to the bus, so that element's going to be needed. You're also going to need an actual circuit breaker or fusible disconnect to feed that unit. So a lot of that sheet metal, as you can see, doesn't have all the mounting provisions for that. So usually the easiest path is that you end up getting either a spare unit or a replacement unit installed with all the appropriate fixings, if you will, to be able to feed that drive.
But wait a second. So when I take this bucket out, let's say that
Yep.
I bought from you. Let's say I called Matt Hussey, and Matt said, I got you covered, Tom. I'm going to give you a bucket. It's going to have a breaker in there. It's got the 3
Yep.
stabs on the back that goes right onto the bus. When I pull this bucket out, are there receptacles behind that bucket ready for the new bucket that I could just plug in, or is it
Yep.
just bare copper bus?
No, there's basically bus connections that should be there. And then the new bucket's going to have stab connections to connect onto that bus. So
Excellent. Excellent. I love it. All right. So now Dawn has another good question since we're looking at a switch, a Cisco switch. He says, where you have an Ethernet switch in the MCC, how do you install the Ethernet cables in the wireways and comply with 725.136? D.
I think that
Huh?
I think that gets into the topic of power limited tray cable versus
Raceways within enclosures and enclosure. So 136D is in enclosures, Class 2 and Class 3 circuits shall be permitted to be installed in a raceway to separate from Class 1 non-power limited fire alarm and medium power network broadband communications. D is associated systems within enclosures. That's the one I think you're referencing. Class 2 and Class 3 circuit conductors in compartments, enclosures, device boxes, non-power limited electric light. So, I mean, I'm not going to read through this right now, but I know when we had Incom and whatnot, we used the blue hose, which was 600 volt rated insulation.
Yep.
So, would you be running 600 volt rated type of wire inside there for communications, or?
You would. The communications cabling you'll find has a similar capability. It'll have 600 volt. It's it'll be AWM rated, so it's intended to be integral to the manufacturer supplied equipment. So we're not looking at it from an installation because it's integral to the assembly.
Okay.
So, but we do provide, 600 volt rated communications cabling. There's a pretty good pictograph on that that I think Belden does to define the differences between 600 volt type tray cable, maybe like a UL 1277 versus 600 volt AWM cabling.
Yeah. But as I read D, it talks about I need a 1/4 inch between non-power limited fire alarm and medium power network broadband communication circuit conductors routed to maintain a minimum of a 1/4 inch separation from the conductors and cables of class 2 and class 3 circuits. So I guess in our construction, we would have to be maintaining that 1/4 inch when we put it together as part of an assembly, right?
It's integral to the assembly, so recognize that is the installation cabling that we're talking about. So our cables are tested or listed within our assembly. So
Good point. So it's a part of the listing. So I may, in fact, be violating some of these distances requirements, but I'm testing it as part of the UL standard together. So as long as I'm a listed product and I'm tested that way, I can get away with doing certain things because I'm going to the nth degree and doing that evaluation in my factory.
right.
That makes sense. But if somebody else installs it out in the field, that's a different story.
That's exactly right. So you'll have a lot of these applications where drives and controllers are all kind of co-located in the panels.
Yep. Excellent. All right. So now as we move on, I'm looking at this. This is a motor. When I first saw this picture, I was like, that's not a motor control center. I got a Magnum circuit breaker there. That's a power circuit breaker. You don't find power circuit breakers in motor control centers. And Matt, you said, yes, you do.
Of course. I think a lot of industry applications utilize it. There's a lot of capabilities there from electrical operation of breakers. Looks like we got some energy reducing maintenance switches there.
Yeah.
Looks like they've also got a Kirk lock on this one, so they might be doing a main application with maybe a generator feed on the other one.
Mm-hmm. We got some meters. And what's that there? Is that surge?
Yep, that's your surge protective device.
Surge protected device. All right. And that's important around motors too. Why couldn't you fit this breaker all the ways in? How come it's sticking out like that?
That's a draw out construction. So,
all right.
Yeah, that's probably it racked out.
Just pulling your leg. All right, there's another line up there, and I see some fusible switches. I know those handles are Malo. Or no, is that a breaker handle?
Those are breaker handles. That looks like it's like a 1200 amp main. I think the other one's actually a generator connect.
Excellent. All right, and there's a nice clean picture. We already saw that earlier.
Yep, and the mains on that one are on either end.
Okay, so you're saying this is the main and that's the main.
Yep.
So wait, this one feeds that line up and this one feeds that line up?
Yep.
Are they connected in the middle?
They could have like a
tiebreaker.
I'm not sure. Yeah, there could be a tie in there. Can't tell with the rail in the way, but
so you're telling me I can have a motor control center that has a main tie main configuration?
Yep.
That's pretty freaking cool. All right. What's this thing here?
That's just HMI for an overload. So
okay.
Overloads have gone a long ways from just being bimetallic overcurrent protection.
Gotcha. Yep. I gotcha. And then you can lock and tag these puppies out.
Yep.
It's a good picture of that. Look at that. All right. What's this right here?
That's a lapse time meter. So say someone wanted to see after how many hours a motor's been running, maybe using that as a maintenance guiding.
Those look like little LEDs. Is that an
Uh,
LED?
that, I don't think on that one. That looks like still looks like a little mechanical one. But yeah, there's certainly other types. That whole area could be populated with a bunch of pilot devices.
All right. Well, Bruce said main time main equals double ended, very common. So, that tells you how many motor control center jobs I've done. I haven't played with my MCCs much in my life. Installed Eaton low voltage MCC that fed remote solar variable frequency drives using NGH style feeder breakers. So we got Ben Bayer who's telling James Ford what he did on a project. So maybe those guys can connect up and work out the details. Or they can contact one of our field application engineers across the country.
Yep.
Okay, next question. I have an MCC that is not only in a wet location, but also in an area where I have pumps pushing caustic water. Is this impossible? I guess they're asking if it's impossible to put the MCC there.
Right. I don't think it would be. There's different enclosure types that we can support. So you'll see different MCC variants of factoring in different environment conditions. And then if anything, electrical rooms will be designed to support it as well. But, kind of like you're showing here, you've got a lot of different enclosure types outlined, meant for different applications, either indoor or outdoor, that can be used to provide that protection. And NEMA provides a lot of good definition as to how those protections line out.
All right. So I had the NEMA document. Let me see if I have this NEMA document up. I hate to do this and try this, but I'm going to do it.
Don says, just get a bigger check.
Just get a bigger. You know what? But here's what I think. I think Dawn makes a very good point. For not that you need a bigger check, but that you really should think about: do you want that piece of equipment in that area? Can you put it somewhere else? And then just run your conductor lengths. Now, you may need a local disconnect for whatever the motor is. You may have been trying to rely on that disconnect for the MCC next to the motor or whatnot, but you probably should consider moving that motor out of that location, because what it will impact is the what do you call the maintenance and all that other good stuff you got to think about. That you've got electronics possibly and drives and all that in an area that is pretty caustic. Now, this NEMA document goes over all the different enclosure types, and here's what I am doing. I on my LinkedIn site, I'm creating a motor control center reference document, and I'm putting links like this in there. So, and any videos
Perfect.
and any design guide documents and things like that. And I will keep populating that. But this is a resource that I'm going to put in there, and probably all of my reference documents I have out there, because this doesn't just apply to an MCC, right?
Correct. Yeah, you could have any of this for any piece of electrical equipment.
Yep. Now, so those are where all the descriptions are. I'm not going to go through that, but now I asked you what types of enclosures can I get a motor control center in, and you said,
yeah, pretty much all the ones that you got starred out there.
Yeah.
You might see the type 1 that's listed there. You might hear it kind of modified with like a 1A or a 1G. Ironically, type 1 is really what you're getting, but they're calling out the fact that all the doors and covers are going to be gasketed, so that from a neatness of appearance thing. But it's a type 1 motor control center.
Yeah, and so what I did here was I went through section 110.28, which is enclosure types. And if you look at 110.28, there's a table in there that tells you which. I'm glad we got guys like Don Ganier on the phone on this one as well, because I'm gonna ask a question, Don and Ryan. and Felix and Mr. Abbasi. Okay, so 110.28 says enclosure selection. And there is a table in there that says for outdoor use and for indoor use. And what I did here was I call these are the degrees of protection, right? So incidental contact with the enclosed equipment, that's the basic fundamental, and every enclosure gives you that. Rain, snow, and sleet, every enclosure gives you that. This is for outdoor use. So I'm going to go one more. Outdoor enclosures, right? So this is the 3R, and everything listed in that area. So 3R, 3S, 3X, all of those, and the 4s, they all give you incidental contact. They give you rain, snow, and sleet. Only the 3S, the 3SX give you the sleet, actually, with a star. I don't know what the star. Mechanical mechanism shall be operable when ice covered. So in any case, what I found interesting was, where's it at? And Matt pointed this out. I have indoor use 1, 2, 4, 4X, 5, 6, 6P, 12, 12K, and 13. Outdoor use, I have the 3s and the 4s and the 6s.
Yep.
And I made the comment, I was like, well, wait a second. I can't use a 3R in indoors. and when I look at the NEC in 110.28, now help me, Ryan and crew, but it says enclosure selection. 110.28 says enclosures other than surrounding fence, blah, 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 of switchboard, switchgear, everything. Terminations, fire pumps, rated not over 1,000 volts, and locations shall be marked with an enclosure type number shown in table 110.28. And it says shall be used for selecting these enclosures for use in specific locations other than hazardous locations. So can I put a 3R in an indoor? When the NEMA document, and it's right there on the screen, it says 3R is enclosures constructed for either indoor or outdoor. But the table does not list a 3R for indoor use. That's my question. So I'd love to hear some feedback on that one.
Yep.
And as we go along,
we had a healthy discussion on that this morning.
Yeah, we did. I was just looking at, and so anyway, so there's the indoor enclosures and the outdoor enclosures, reference 110.28. And what you noted was, I'm just going to go back to those stars again. You can get a 1, 2, 4, 12, and a 3R in a motor control center.
Yep.
Okay. And then those enclosures will dictate where you can put it. All right. And let's keep going. And this I'm just looking at the informational notes. They tell you rain tight, rain proof, and what those are. So keep that in mind. So I was grabbing some of the pictures you sent. What is that, stainless steel?
Yeah, that's a stainless steel one. So that's basically a NEMA 3R, and then they have a stainless exterior for it, kind of providing some protection against any type of erosion and stuff.
And then that's another picture from the inside. Anything special about that image?
No, that's just kind of what it looks like on the inside. I think you can kind of see some of the bus that we're talking about. You kind of see it in the middle there. It's an insulated bus. And then the units are on the front, so it's a good cutaway of what looks like behind the doors.
Excellent. And then the only other comment I had is maintenance, which I already touched. You know, that's an important aspect. What about a hazardous location MCC? Do they exist? What do you think,
Of course.
Of course. Kraus-Heinz switch racks. And you know what's funny is I saw one of these down at the Houston Experience Center. And I didn't know they had a specific name for it. I just thought they put a bunch of parts together and made some controls there. But that's it's a listed switch rack for a hazardous location, and that's like your MCC, but just for a HAZLOC location.
Yep. And the bus or power conductors are routed at the top there, and then each unit is fed off of that.
Excellent.
And they also have to consider some things like purging for certain environments and things like that.
All right, so Ryan Jackson's note about the location. It says he doesn't see, Ryan and Dawn, I don't see any actual restriction in 110.28 that would prohibit the use of 3 or 3R for an indoor application. And then Ryan noted that 110.28 just says enclosures intended for indoor must bear one of the markings. It really does not say thou shalt only use these in indoor or outdoor locations. All right, so I have to go back to 110.28, the parent text, before you get to that second paragraph. But all right. Now, 430.1 informational note points us back to 110.26e, telling us that installation requirements for motor control centers are covered in 110.26e, which, if you look at 110.26e, it just it says dedicated equipment space, and this is what's talking about your indoor and outdoor locations. It hits, and I think I put the titles in there. Dedicated equipment spaces, but it covers also switchboards, switch gears, and panel boards. MCCs are in there. And then you have your indoor. You talk about dedicated electrical space, foreign systems, sprinkler protection, suspended ceiling, and then you have your installation requirements, working space, dedicated equipment space. Okay. All right, so next question. Can I put a panel board inside an MCC? So we talked about putting a circuit breaker. What about putting an entire panel board inside of an MCC?
Yep.
Yes,
yeah,
you can.
it would be a UL 67 panel board, all kind of different units.
So I went back to 845, and in section 1.3, it says a motor control center can contain, but is not limited to, any combination of equipment. Full voltage reversing starters, which you would combination motor control units, combination motor control units, reduced voltage part winding. But look at that, they have a whole bunch of stuff in here, which I was pretty surprised to see. I mean, you have your lighting and distribution panel boards right here. Whoops. Pen, lighting, and distribution panel boards are right there. Feeder tap units are there. Control lighting transformers are there. Special equipment assemblies, combination contactors. So your panel boards are covered right there, and there is a picture of a motor control center with a panel. Now, if I wanted to do that after the fact, is that doable, or it looks like it's taking up 1, 2, 3 spots for that. Is there a way to, could you convert these three, pull those buckets out and convert that over to put a panel board in it?
You could. They're cable fed, so main lug only panel boards. You'd have to change the space out, obviously, but you could procure basically all that in the right stack dedicated unit. You can see we've got some specific dead fronts and unit construction that the panel board fits in, but pretty handy.
And it's in a bucket too. Is that white right there? A bucket, right?
Yep. That's what I was saying. It's mounted inside of a bucket. There's no power connections made because it's a main lug only panel board, but.
And that's similar to our IFS type of solution where you have the This is not an MCC. This is a switchboard that has the transformer. It has all your panel boards all in one unit. And, and the reason we do that stuff is makes it easier to install. It's a lower cost. Puts everything in a nice tight space, which is nice. It's all a tested unit together. All that good stuff. Excellent. Can you put a transfer switch inside an MCC?
Of course you can. We can. You could do some things like this where it might just be a main incoming for normal and an emergency supply. This one actually might be one, Tom, where even the bus is split, where you got, say, under normal operation, an entire lineup is fed for a typical use, but then if an emergency supply, it's transferred over, maybe only parts of the lineup are fed.
Cool. Excellent. So, and now I threw this picture in too, because what's that down there?
That's your distribution transformer.
Yeah, so you could put the transformer, the panel boards.
Yeah, and actually the panel board for that one looks like it's kind of hiding back there on the right in the adjacent section.
Over here.
Yep.
Yeah, so
And
you
that's
got.
actually in a NEMA 3R enclosure too.
Oh, that's a NEMA 3R. Yeah, yeah. And then I saw you sent this one over. What's this one here?
That's a soft starter with a bypass.
Ah, okay. And now, so that brings up a good point. You know, when you throw in a variable frequency drive or some of those types of things that isolate from an inrush current and from a short circuit contribution, when you put it in bypass mode, you know, it bypasses all of that insulating or isolating type of equipment. So when you're doing your short circuit studies, you've got to make sure you include that motor contribution because you have those bypass switches in. Oh,
Yep.
Felix Sandoval has a good question. Can I put a fire pump controller inside an MCC?
I've not typically seen it. I know there's some special considerations there on it being located, upstream, but I've not run into it myself.
No, but not that it's not that not that you can. It's not that you can't do it. It's just that you've not done it. But it could be possible, I guess, right?
It could be.
I don't know that you would, but anyway. Says yes, be careful and check each case with the local vendor rep for distance, with type of power wiring, etc. used. Sometimes you have to use welding cable for power, etc. Limit of 200. All right, control. All right. So we got some good dialogue going on in the chat, which I appreciate that, and I think everybody appreciates that. So is replacing a failed starter considered a reconditioning based on the new NEC requirements? Can I recondition an MCC? First question, what do you think?
I would say that replacing a failed starter is considered the normal servicing of the equipment. So we're kind of in that case, we're just changing out a like for like.
Okay, and then can you recondition a motor control center?
Reconditioning as defined as?
Well, let's take a look. So in the NEC just recently changed in the 2020 cycle. So I'll just show the definition. So this is the definition of reconditioning. Electromechanical systems, equipment, apparatus, or components that are restored to operating conditions. So you would have to have a motor control center that gets nailed somehow. Flood, earthquake, and it fell over. I don't know, maybe a truck ran into it and it's all bent up and it's no longer functional. So the first sentence in reconditioning establishes that it's any piece of equipment that wasn't working and now when you get done, it is working. So if I had a motor control center that quit working because I don't know, maybe water damage, maybe I hit it with a truck, all that good stuff, can I recondition it? Get it back up and running again?
Probably need to verify, when you're going through that, how you'd be able to do that. There's some NEMA policies out there for dealing with things like water damage and reconditioned equipment. But in any type of substantial work, usually it's starting to get into a point where you got bus that's damaged or things like that. It's probably best to look at replacing that.
All right, so I'm going to put the NEMA water damage report as a link to my reference documents. But that's a good point. But in 430, they didn't put anything in Article 430 that says you cannot. I know the NEMA policy document says you can't.
Yeah, I think the dialogue that I've heard is that there's concern over extent. Right? So if you're doing something to say a door or something has been bent or things like that, and you want to get a replacement door, is that considered normal servicing or is that, restoring it back to operating conditions? And then obviously there's a lot of concern if some of the damage that you're trying to repair the equipment off of is a result of, like a short circuit event or something like that.
Ooh.
How do you know that the rest of the integrity of the equipment's still intact?
So good
So I
point. So
think that,
if you had like an arc flash event in one of
right.
those cubicles, and you're going to take everything out, get it all back up and running again, you're questioning, how do you know the integrity of the bus, all the way the bus is installed and connected, the insulation that might be in there, and other areas
Yep.
of that MCC. Good point. Good point. Because you can't do, once you recondition it, you can't do a field short circuit test or anything like that.
Nope, those are failure tests.
All right. And now the definition in 100 says it differs from normal servicing of equipment that remains within a facility or replacement of listed equipment on a one-to-one basis. So that answers the first question, that if I had a failed motor starter and I take the old one out and put the new one in, that wouldn't be reconditioning. If it's a one-for-one. Now, if I
Correct.
took
Comment there from
if I took your starter out and I put a Square D starter in, can I do that?
if I don't have a combination for any of those, so I
Right.
don't. You're probably not going to have that short circuit combination rating.
Yep. Don Ganir asks, is replacing the vertical bus a repair?
Replacing vertical bus of repair. Well, it's obviously changing. That vertical section is listed. I don't believe it. What would constitute that being repaired?
So if you would be replacing the vertical bus for a reason, right? I'm not sure
Right.
why you would be replacing it, but for whatever reason you're replacing it. To your point earlier, you're questioning the integrity of the whole thing. We don't have manufacturer's instructions on how to do that in the field, right?
Right.
So
Yeah, usually, if anything, there's buses designed to be added on to different sections or sections removed, but that's always to usually replace it within a new section.
Gotcha. All right. So you got the one for one. What else? You got the section includes 2 first-level subdivisions, equipment markings. Now, once you define that what you're doing is reconditioning, then the 110.21a marking requirements tell you got to remove the original listing mark. You have to put your name on that equipment, that you are the now owner of the reconditioned equipment. You're now the new responsible party, basically. And then they put in the exception for equipment that is reconditioned by the owner or operator as part of a regular equipment maintenance program, is part of the exception. So, I think if how I would determine whether or not something is standard maintenance procedures is if we have things written up telling you how to do something, right?
Yeah, I think that's a good point, Tom. It's as long as a manufacturer has some features or things intended so that they can walk someone through their process to make sure it's done correctly, because you're certainly getting into, especially from a bus system, you're getting into, changing out some of the hardware and things like that. Hopefully it's restored to the same state, which obviously would need to get some manufacturer input on.
Yep. And then finally, following manufacturer's instructions to install accessories and a variety of electrical equipment is not considered reconditioning. And again, even though there is nothing in 430 that says you cannot recondition, or it's telling you can per the NEC, but then you would have to go back to the definition and understand whatever you do to that equipment, if it's considered reconditioned, and then go to 110.21 for the marking requirements to say you got to remove the listing mark, put your name on it, and do all that kind of stuff. And that's for traceability and transparency reasons, basically. So looking at some of the questions, Felix asked, are buckets in the MCC considered each a separate enclosure?
I think you could say that that's the case because each one is defined as its own compartment, which you've got a door and a unit all
Together.
constructed together. Granted, they're all installed in a complete lineup with multiple vertical sections. I'm sure when we test it from an enclosure type classification, it's assuming all the rest of the doors and things are closed up. So I think you could look at it as the entire lineup being the overall enclosure, but then you got each unit representing each compartment.
Yep. Perfect. All right. Let's move on. Can I expand an MCC with more vertical sections? Does that void my listing, my warranty? So we threw
Nope.
some
Yeah.
pictures together, and why don't you speak to, if I had this line up here, which is 4 of 9, so that means I have 9 vertical sections. I want to put number 10 in. Can I do that and connect it? Right. So when I want to put 10 and I want to connect it to the main or horizontal bus.
Yep. Yeah. MCCs are designed to be added on and removed. So if you add a new section on there, you'll find that it'll have its own listing on it. Usually manufacturers will allow for, designed in splices for their equipment, or if possible, designing into made up to other pieces of equipment. But usually that's all defined as we've provided tested arrangements for it.
Okay. So they're designed to be added on to. Is there a limit on how many sections you can put?
Nope. It's just the amount of current
Okay.
that is able to be carried.
Okay. And so what about amp rating of bus? Like if I'm going to add 2 on it, or say I have 2 that are existing, freestanding, and I just say, you know what, I got rid of those motors. I'm going to take these 2 freestanding units and I'm going to put them on this. What are some of the things I need to think about?
I would want to know, one, that what the bracing is for the structure. So you'd want to know that the equipment has the same sort of short circuit current rating for it. You also would want to know that it's got the same ampacity on the bus to be able to connect those. And usually you're not changing from one horizontal bus ampacity to another.
Okay. What are these, 30 cycle structures?
No, these are 3-cycle. So UL 845 identifies MCCs as 3-cycle products.
Only 3 cycles.
Yep.
So
Yeah,
what-
that goes back to, they were originally designed and built around the application with molded case circuit breakers, which are short circuit devices for 3 cycles.
Okay, so that means I have to be in the instantaneous region of
Yep.
the feeder breaker with the bolted fault current, right?
That's correct.
Okay. So can I buy a 30? I can't even buy a 30 cycle if I wanted it?
No, it wouldn't be listed to, if a manufacturer did, they would have to have gone through the lab to validate it. It wouldn't be listed as a 845 motor control center, but basically a area of investigation.
All right. So if I have a power circuit breaker supplying it, how would I meet the 3 cycles with a power circuit breaker?
You'd make sure that the instantaneous was enabled.
And the instantaneous of that power breaker can get me 3 cycle clearing times, even though it's a power breaker?
Correct.
Okay. All right.
Yeah.
Okay. Well, that's interesting. That's good to know. Product testing, evaluation, and listing shall be performed by No. So this is anytime so I think where our discussion is if you're going to make this change in the field, you're going to take an MCC, you're going to extend on, even if you even if I bought a new one, I probably should get somebody to look at that installation, like some sort of nationally recognized testing laboratory. Or if I bought one from you, the manufacturer, would I need to get a field evaluation?
Correct.
Okay. So you would be employing some field evaluation body to come out and take a look at that installation as you're modifying it in the field, because it's not as it was when it shipped. You'll have that label that says 1 of 4 or 1 of 9, 2 of 9, 3 of 9, 4 of 9, etc. And that those two sections will still say 1 of 2 and 2 of 2, but your documentation or somebody would have to document that it is now part of this whole motor control center.
Yeah, you want to be able to trace back to its original equipment designs and whatnot.
Yep. Okay. All right. Okay, so that's all we had on that one. So we can add a vertical section. We would want to get it looked at. There are some details like the bus ampere ratings, short circuit current ratings, physical connection, etc., to make sure that all that's done correctly. So you're going to probably get a field evaluation once you get that done. All right, so how often am I supposed to pull maintenance on an MCC, and what maintenance should I do?
Got some good information here, Tom. You got the manuals that kind of talk about it at regular intervals. A lot of the maintenance features you're going to find on a MCC are certainly around things like bus connections, tightness, that, and then usually complemented with any component maintenance interval.
Yeah, and so what I did was I pulled up the Freedom. I grabbed one of our motor control centers.
Sure.
And this is the installation and maintenance manual for that motor control center. So let me do this. I'm going to do just. I'm just going to walk through this one. So I'm just showing. I'm just going to show the document itself. So I know it's in part 10. So you got part 1 is just general information. So let me zoom out and get down to number 10, section 10, which is on maintenance. Now, 70B is going to be including more information. Just as I'm trying to find this so everybody knows, 70B is going to a standard, and we're working on that right now. Myself and Bruce Campbell are on 70B, and actively working on converting that over from a you can do this and you should do this to a you shall do this. Now here is our maintenance document that talks about preventive maintenance. Should be a program, a scheduled periodic action that begins with the installation of the equipment. At that time, you have to follow the manufacturer's instructions, store those for future reference. It says follow-up maintenance should be at regular intervals as frequently as the severity of the duty justifies. And that, I would think, would be the conditions that you're in from a motor control center, the environment, and probably how often it's being used or cycled or whatnot. I don't know. I don't know if you have any thoughts on that, Matt.
Yeah, I mean, certainly a lot of applications. It's can go many years of operating successfully, but obviously if you're in some sort of very intensive industry environment, a lot of high switching currents and things like that. Contacts on contactors may need to be looked at. Really just trying to handle the variety of applications it's going to experience.
This says time intervals of 1 week or 1 month or 1 year. I mean, could you imagine having this thing in a location where you have to go over weekly?
Yeah, it's pretty intense environment at that point.
That's what I would think. I would advise not to put it there. And it talks about that, who should be working on it. When servicing and adjusting the electrical equipment, refer to the applicable drawings, etc. List of instructions and leaflets. The whole purpose of maintaining electrical equipment can be summarized in 2 rules. Keep those portions conducting that are intended to be conducting, and keep those portions insulated that are intended to be insulated. I like that.
Yeah, you like that?
That's kind of, I mean, it really simplifies it, doesn't it? Good conduction means clean, tight joints, free of contaminants such as dirt and oxides. Good insulation requires absence of carbon tracking and the absence of contaminants, salt, dust, etc. And then, and so we got mechanical checks. We've got electrical tests that we can do. Cleaning, look for soot, smoke, stained areas. blown clean, and I would say de-energize it before you start getting in there with an air compressor, for goodness sakes. Remove arc covers from contactors. Okay, so we give you some good, half-decent outlines, and there are other standards, I'm sure, out there for motor control center maintenance, etc. You're looking for contact wear, you made that point earlier that the contactors and things like that are always operating. That's typically what you're going to be looking at, right?
Right. Yeah. They're designed for millions of operations and things like that. Over time, those things are opening and closing on circuits. So to check through those contacts and make sure they're working well.
Yep. All right. All right. So I have a reference on that. So now I put this in there because I think that there's technology out there that if I had additional information, I could probably help strategically plan my maintenance on a motor control center, because I would get to know certain parameters. I mean, is that stuff out there? I know we do it, like our new breakers, our new power defense breakers tell you how many times they were opened. They tell you how many short circuits they hit, how many overloads they hit, all that good stuff. What are we doing in the MCC world?
Yeah, that's Tom, we talk about this quite a bit where, we got this great irony here of this equipment being out many years. I think even Don was mentioning, they've got installations for 20, 30 years. And so what you see going on in industry is this switching of how equipment is maintained over its lifespan. Normally that's kind of handled from, regular intervals or planned things. And so it's only but a snapshot in time. So if somebody is trying to catch something as it's fatiguing or wear, we know that occurs, and it may occur at different time periods and things like that. So what's going on is there's a lot more capabilities that we can now tap into. A lot of the devices, the equipment can be embedded with different intelligent devices, intelligent sensors, and things like that we get a better look at what happens to the equipment over the lifespan. So now you can start to identify failures impending, before they actually occur. It's preventative maintenance is only good if you can actually get to that point and identify it before it occurs.
Excellent. And I just popped over to Facebook, and there's a gentleman out there, Jeff Fecteau, who is with UL, great guy, and 24 minutes ago and 14 minutes ago, he posted a couple cool things. He says, on the question of a fire pump controller in the MCC, he says, look at 695.12a. So 695.12a says, electric motor-driven fire pump controllers and power transfer switches shall be located as close as practical to and within sight of the motors that they control. So I guess that's probably a parameter that you've got to think about with regard to the placement, if you're going to be in an MCC, where that MCC is going to be located in relation to the fire pump controller and the transfer, so all that good stuff. So it may be that MCC that you're going to is not within sight of the motors that they control. So proximity of that MCC in a fire pump application is going to be probably an issue.
Yep.
And then he also said ULCCN AALZ states that all outdoor type enclosures provide a degree of protection against rain, snow, and sleet. Outdoor enclosures are also suitable for use indoors if they meet the environmental conditions present. This includes 3R. So that's a good. Those are. I gotta. You know what? I've got to get better at my invitations. I put it on my LinkedIn. I put it on my Facebook. He said he's not getting my invitations. Well, I'm, and that's probably true. I don't know how to get in front of more people without. All right, so this is good. All right, so we talked about smart MCCs. Anything else on that, Matt? You're muted. I can't hear you. You're not moving anymore. Okay, the next section is, are the terminations in an MCC 90 degrees C, 75 degrees C, and then how do I know? So, I think I lost you, Matt. I'm not hearing or seeing you move, so hopefully you're not watching it on
You
YouTube.
there?
Yeah, yeah. Be careful on how much you stream because your pipe going out can only handle so much, and if you're doing too many things, it can kill you. All right, so now tell me, am I using 75 degree C or do you make a 90 degree C MCC?
75C terminations.
75, that's it. So,
Can you hear me?
yes, can you hear me? I can hear you
Yep.
fine. All right, so I'm looking at our instruction book, and it says install the line and load conductors sized in accordance with the NEC. Here, I saw this was interesting. It says use copper wire only for control terminations. So I can't use like copper clad aluminum or anything like that.
Yep.
Is that because is that specific? I meant to check on this in the standard. I didn't. I was trying to see, is that something specific to our installation, or is that something a standard based thing? That's just what we do, or is that driven by the standard? I'm not sure. But it says for power terminations, use copper wire only for power terminations unless they are marked CUAL, copper aluminum. Conductors with temperature ratings of 75 degrees C or higher. And it says or higher because we got to remember, I can wire with 90 degrees C insulation, but I still have to use the 75 degrees C column as per for our 110.14 requirements. Regardless of the insulation temperature rating, select the wire size on the basis of a 75 degree C wire. And what that means is you select it based upon the ampacity of a 75 degree C wire. All right. Okay. What about the standard? I've got to look at the standard. I put that in for me and never went back to the standard, so I'm going to have to do that later probably. 110.3 talks about installation of use. So 110.3 tells us we need to follow the manufacturer's instructions, and what I just read to you is part of the manufacturer's instructions. So control wire is always going to be copper at least in this assembly, and then you have to use copper wire unless it's marked CUAL. 110.14 talks about the terminations, and remember, the 110.14 talks about torque and pressure connectors and how do you pull things together. They have the terminals, the splices, the temperature limitations, which is really what we're getting to here in this discussion. I mean, obviously you've got torque requirements. I mean, you published your torque requirements for the motor control center, right, Matt?
Yeah, they're in that same manual we're looking at.
Yeah. So we have our torque, and do you put it on the buckets or anywhere inside the MCC itself?
Yeah, you'll see it marked in the, there'll be a sheet that goes over any types of power terminations, the torquing requirements there too.
Okay, and I'm just looking and I should never do this. I have this. Did you ever see that movie Up?
Yeah.
Where the dog would go, squirrel, right? That's me. I just looked over and Mr. Abbasi says, also look at 695.4B3A3. And so that was like squirrel. 695.4B. Where is 695.4? There's 3. 695.4B. Boy, my glass. I need glasses. Here it is. B 695.4 B3A3. B3 disconnecting means so 694.4 is continuity of power. B is connection through disconnecting means and overcurrent devices. 3 is disconnecting means. All disconnecting means devices that are unique to the fire pump loads shall comply with items 3A through 3C, and 3 A3 says, A is features and location, and 3 says not to be located within the same enclosure, panel board, switchboard, switchgear, or motor control center with or without common bus that supplies loads other than the fire pump. Well, there you go. So if you have an MCC, Matt, that's supplying motors that are not the fire pump, then you cannot put that in that motor control center. Now, if I had three fire pumps and I had a motor control center that fed those three fire pumps, I might be able to do that because it's just the fire pumps.
Yeah.
With or
But
without common bus that supplies loads.
I would agree with Bruce. I don't know that I've ever seen it being done.
Nope. All right. Well, but it was good to explore. That was fun. All right. So you got to worry about the terminations. You got to worry about the connections, splices, temperature limitations. Again, it's a 75-degree C piece of equipment because of all those overcurrent devices that we have in there. You've got all of the overcurrent devices that you're terminating on, and you got to consider that. That's right, Bruce B. There you are, separate enclosures. All right. Okay. How would the MCC or the controller might be at the ATS all on the same site of the... Okay, so let's talk about short circuit current ratings. What do you think? You ready for that, Matt? So what is the short circuit current rating of an MCC, and what does it mean when someone says rated for 3 cycles? Now, I'm looking at this label. Do you put this on all MCCs?
Yeah, that's what we would call like a master nameplate. But you can see there's the short circuit current rating identified there. In this particular case, it looks like it was a 100 kA lineup being utilized.
It says, do not stall on circuits with short circuit currents higher than the lowest. Okay, let me ask you this. So this piece of equipment is rated 100,000 amps.
Yep.
That means that no overcurrent protected device in this equipment can be less than 100,000 amp interrupting rating, right?
Correct. Or the combination rating is at least 100 kA.
Or the combination rating. That's exactly right. Okay. So really,
so you could have a contactor that it has a 10 kA or maybe a circuit breaker that has less, but if it is utilized in a combination, it might actually obtain that 100 kA.
Okay. All right. And then is there anything else on this label that's important to us? I mean, we got the section 2 is 800 amps.
Yeah, those are designating the vertical bus ampacities, and then you've got the horizontal bus ampacities mentioned above that. Okay,
the horizontal buses. This is a 2500 amp.
Yep.
What's 65? What's that 65?
65°C rise off of the horizontal bus. So 40-degree ambient condition. The bus is rated to not temperature rise above 65°C.
Okay. So then we have the vertical sections, 800 amps, 1200 amps. It looks like there's 9 sections in this. And it says section 1, 3-5 none. What does that mean?
Yep. So section 1 probably doesn't have any vertical bus. Largely it's probably because there's a main. So that main might be connected directly to the vertical or to the horizontal bus. And then 3 through 5 would be maybe that's utilized as like a big relay structure, or maybe a large drive, which also could connect directly to the horizontal bus.
So it says that this is a 2500 amp main, so that's a 2500 amp piece of equipment. What's the largest amp rating MCC that's made?
You'll see typically around 3,000, or in our case, we do 3,200 amp.
3,200 amp. So I couldn't get a 4,000 amp MCC. So
no.
All right. Okay, so 3200 amp MCC. This is a 2500 amp MCC. It's got a main RGC, which RGC is the breaker. So that's specific to us, an RG type breaker,
Right.
R frame. And that means that it would have an arc reduction maintenance switch on it. It would have ground fault protection of equipment. No. Yeah, right?
If it was service entrance.
If it was service entrance, yeah. So short circuit current rating is the ability for that to, we only got 10 minutes left. So the short circuit current rating is the ability of the equipment to pass through the fault current, to let it pass through, not stop the fault from flowing, but to let that pass through. And there's a definition in Article 100. It's not an interrupting rating. It is it is the rating of the motor control center that basically you can hold it together under the magnetic forces of the fault current passing through it to the load. And the best thing that I like this diagram best because it really shows that the fault is actually not in the equipment. Like this would have to be the MCC. The fault is downstream, and then the current is passing through that equipment, and all of those components that are carrying the current have to hold it together under the pressure. And I relate this to my weightlifter example, meaning that this guy here is the electrical distribution equipment. The weights over here are the magnetic forces pressing down on it. This guy here is your spotter, and the spotter is basically there to make sure that the distribution equipment doesn't get hurt, right? So, and that's the overcurrent protective device. So the key thing that you got to think about from a short circuit current rating is that equipment has to be able to withstand it. And we know, based upon what you told us, Matt, it's a 3-cycle withstand rating, right?
That's correct.
So that says I can only stand 1, 2, 3. That is it. If you let more than those 3 cycles flow through that MCC, we could experience some bad things, right?
Yeah. That's where we go back to, even the compartments. I think your example kind of shows that really well with the fault current flowing through and the equipment has to hold it together. So that's really important with all those short circuit current ratings is that equipment is designed to still handle it and hold it together.
Yep. And one of the things we do, and I'll show both of these, we do to help people understand the magnetic forces that are present on electrical equipment as they pass through, as it passes through equipment from a short circuit perspective. We do a test down at our Busman facility in St. Louis. We have 90 foot of 2-watt conductor, which is pretty stiff. We take 45,000 amps at the source. We let 26,000 amps flow through it for 1 cycle. And this is the result of that. So that is 1 cycle of fault current flowing through that conductor. And what we show is that the peak let through that first half cycle was 48,000 amps, and the I squared T, which is the heat, the energy, was 15.7 million amp squared seconds. So then what we do is that exact same test with a 200 amp fuse, which 26,000 amps is going to be well into the current limiting region of that 200 amp fuse. And this is the result, and what you have to do is watch right down here. And there it was. So I'm going to do that one more time in case you missed it. Can I do that one more time? So that 3-cycle clearing time, in that case, you're less than a quarter cycle. You're translating into less magnetic forces on the power distribution system. We went from 48,000 amps peak to 10,000 amps peak, and from 15.7 million amps squared second to 127,000 amps squared second. So that's a big difference in from a peak current perspective. The short circuit current ratings are required to be marked on the equipment based on UL 845, NEC 430.98, and 430.8. So if you look in 430, you'll have the marking requirements for motor control centers. And you have to document the maximum available fault current at that motor control center based upon 430.99. You don't have to mark it there. You have to at least have that available fault current documented and available to the HJ. And then you always have, based on 110.10, you have to make sure that the short circuit current rating is greater than the maximum available fault current at that equipment. And 430.8, the marking on those controllers and whatnot was entered into the National Electrical Code during the 2008 cycle, saying that, but really the standards cover you. I believe that's what you do. So 430.8 short circuit current rating is item number 4, and then you look at that. They made some changes in the latest version of the code. They pulled some of the, I guess that's really related to HVAC equipment, but in any case, not required to be marked when the marking is already a part of the controller or the assembly, which we already do. So you don't have to field mark these things. We already have all of that on the equipment. But they will have to calculate the fault current and make sure that it's being applied correctly. All right. I'm looking at my watch. We got 2 more minutes. 430.99 is the available fault current. This is new for the 17 available short circuit current at the motor controller center, and the date the short circuit current calculation was performed has to be documented and made available. So that's an important new requirement in the 17 code. And that didn't change in the 2020 code. I don't think they went to markings. These are all the things that have to be marked and how they're supposed to be rated. They got to be a motor control center section shall be rated as follows: voltage, phase, frequency, and the bus short circuit current ratings, the horizontal and vertical bus ampacities, which we just saw in that label previously. And then the motor control center unit, which that's the bucket, has to have the voltage, phase, frequency, the load, and then in Mexico, I guess kilowatts is required, and then the unit short circuit current rating. So each bucket will have a short circuit current rating as well, right?
That's right.
Excellent. The horizontal bus rating, that's the common power bus that goes across the top when you have more than one vertical section. 600 amps or higher. Preferred ratings are 8, 1,000, 1,200, 1,600, or 2,000. What do they mean by preferred ratings? And that's out of the standard.
It's probably like nominal rating increments that are referenced there.
All right.
Kind of like circuit breakers, where you kind of have a typical increment from one range to the next.
Right. And you said the largest amp rating on a horizontal bus was what again?
At least to what we make is 3,200 amps. I'm not sure if there's another manufacturer that has something larger than that, but.
All right. And then the vertical bus shall have a minimum continuous current rating of 300 amps, but it can be. I guess can the vertical bus be 2,000 amps?
It could be. We make one that goes up to 1,200 amps, but.
Perfect. And then this is out of the standard with regard to the short circuit. Just talking about containing only control, how you work through the short circuit current ratings inside of that motor control center, and a lot of this is lingo. We don't even need to. We're not going to read through that. We're at time right now. So here's what I think we're going to do, Matt. We're going to do a part 2 to this. I'll schedule that. And we'll continue our discussion with this question: are line side barriers available for MCCs that are service entrance rated? And I believe that's going to take us into the new 6 disconnect rule and everything else that's associated, because as you said, we have service entrance type equipment motor control centers. All right, so we're at the top of the 2 hours. What I'm going to do now is as we read through the doing things working in the house. So All right, guys and gals, thanks for stopping in. Take care, God bless, and stay safe. I'm going to end the stream now, Matt. And here we go. We're saying goodbye. Ending the stream. End. And I also have to end it on Facebook.